Alright, hello once again. This is Jeff Scott of Blackhawk Technical College. I've been going over the PowerPoint presentations from our textbook, Murox MySQL 2nd edition, for the 152-147 Relational Database Development class for the spring 2016 semester at Blackhawk Technical College. We've gone through the first 9 chapters, and now Chapter 10 is the beginning of Section 3, which is entitled Database Design and Implementation. So in this chapter, we're going to learn how to design a database. In the next chapter, Chapter 11, we're going to learn about the data definition language, or DDL, statements that are used to create and maintain databases, tables, and indexes. Finally, and then in Chapter 12, we'll talk about views. And in many ways, a view is a saved query. So again, we're now going to go over Chapter 10, where we'll learn how to design a new database. Alright, so the database that they're going to use for this is the AP, or Accounts Payable database, that they have been going through throughout the entire text. So, taking it from the top, here are our objectives. So given some specifications, be those written specs, some kind of file someplace or whatever, start to identify the tables that you're going to use for your database, the columns in each table, keys, be they foreign keys or primary keys, relationships, be they one-to-one, one-to-many, or many-to-many, which again you'll have to make changes to, but and indexes for a database. Then we'll talk about normalization quite a bit. All right, there are actually about 7 different normal forms, of which normally, no pun intended, a business only goes through about the 3rd normal form. In the last part of the chapter, they talk about using MySQL Workbench to create or work with an EER model of a database and the associated diagrams. All right, give 3 criteria for when a column should be indexed, describe the concept of referential integrity, and talk about how MySQL works with referential integrity. This will have to do with cascading and a few other things. And then explain how normalizing a database can help with performance. All right, so what they're getting to here, and I think you can all look at it and understand, but really what the author is basically saying right here is that a database is kind of a reflection of what's going on in the real world. So in the real world, you might have a system that basically very much of it was done with paper documents. All right, and that said, it's not that there's anything wrong with paper documents, but they get lost, they get misplaced, they get taken, whatever. And technically, if you want a permanent copy of them, what you're going to want to do then is you're going to want to take your data and put it into some kind of either a database system or a file system. All right. Well, what's in vogue today is what's been in vogue for a long, long time, and basically what that is it's saying that rather than using a file system, you're better off using a database system. So again, you already know this, as they show there. Databases are made up of tables. Tables are made up of rows or records. Rows or records are made up of columns or fields. All right, so again, there's nothing that's in there that's really new. So the author comes in here and gives you this 6-step process for designing a data structure. Number 1 says that you go through everything that you've been working with and you identify the data elements. Now, when they say data elements, this could be different things. This may end up being what ends up being your tables. It could end up being what is the data in your tables, etc. So, but you're making a first pass at it, so to speak. Then you start to subdivide the elements into their most useful components. For instance, let's say that you've got something that you're creating, and whatever that is that you're creating has in it, amongst other things, maybe the name of a contact. Well, you probably will want a contact first name field and a contact last name field. In other words, you typically are not going to want to have a contact in there that says contact name, where you combine both the first name and the last name together. You typically wouldn't want to do that. All right. From there, we go on into step 3, and we identify our tables, and we start to go in and assign our columns. Step 4, we're identifying our primary keys and our foreign keys. Step 5, and this is the one that can take quite a long time, because in there what we're doing is we're figuring out whether or not what we've been working with is normalized or not. All right, and then finally we go in and we identify the different indexes that we might need. So that's what this chapter is about. All right, so when you take a look at the picture that's here, this is step 1, and the author's starting to talk about this is an actual paper invoice that a company has that's used, as it says, to identify data elements. So you can see you're going to have some invoice information here. You're going to have some vendor information over here. And you're going to have some invoice line item information here. Some salesperson information here. Some accounts receivable information over here. Okay? So what they've done in step 1 here, as you can see up on the screen, is they've gone through this and they have figured out the data elements that are in this document. We already talked about this, when you start to talk about dividing things. Another one that you might want to consider dividing, as an example, do you want the address to be into multiple fields? In other words, address, city, state, and zip. Typically you'd want that because there's a good chance that if you want to be writing queries, you might want to write queries of everybody in a certain zip code, or everyone in a certain city, or everyone in a certain state, as an example. So you typically, again, would want to be breaking those up into multiple fields. And there you go. So you start to go through this and you say, okay, what would we want in here possibly for tables? Okay? And it's interesting when you start to look through there, you'll notice that there's a bunch of stuff there that's scratched off. All right, fax number, web address, and that, what they're doing right now is they're saying this information is what's going to go into a vendor's table, this is going to go into an invoice table, then we've got more information that goes into the vendor's table. Now we've also got an invoice line items table. All right? You have to start thinking about what you want to store and possibly what you don't want to store. All right? So it says data elements that were previously identified but aren't needed are crossed out. Data elements that were added are displayed in italics. Data elements that are related to 2 or more entities are followed by an asterisk. This is just the way the author is recommending that you do this. It's not, again, that you have to do it this way or don't have to do it this way. This is a suggested method for doing things by the author. So, then as we come in here, what we're doing next is we're starting to identify the relationships between tables. Again, this should make sense. One vendor can have, and this is that crow's feet, 0 or more invoices. One invoice can have 0 or more line items. So you're starting to create the relationships between the tables. And you notice one to many, one to many. So we've taken the primary key from our one side and put in there as a foreign key on our many side. We've taken the primary key on our one side and have it in there as part of a primary key on our many side. Now, this is something we haven't talked too much about before, but we will right now. And that is this. If we've got a table or two tables that we want to link together. So when you look at the example right here, let's forget about this memberships table that you see in the middle. Let's pretend that right now you had two tables. One that was called employees, that had an employee ID, a first name and a last name. One that was called committees, with a committee ID and a committee name. There really is nothing, we could go and take really there's a relationship where technically 0, 1 or more employees could serve on 0, 1 or more committees. So there is a many-to-many relationship. So what we do is we pull the primary key out of each one of our tables and create a new table. We could put other information in here if we needed to, but at a minimum, this is called a linking table. It's sometimes called a jump table or a join table. All right, but the idea is the sole purpose of this table, memberships, is to provide primary keys so that we're able to link the two tables that otherwise we wouldn't be able to link together. All right, now here's a one-to-one relationship. I talked about these a lot earlier, and one of the things that I mentioned in here was when you have a one-to-one relationship, technically we could have combined all this information into one table. So we could have had one table with employee ID, first name, last name, and an employee photo. But we broke it into two. But it's a one-to-one relationship because of the fact that for every one employee, there will be one employee first name, one employee last name, one employee ID, and one employee photo. All right, we've talked about the concept previously of referential integrity. So let's talk about it again. All right? Okay. When you've got a setup like this here, something like this, okay? Right now, it is not considered to be acceptable for me to be able to come in, so I cannot come in and remove a vendor while that vendor still has outstanding invoices, because the one side is the parent table, the crow's feet or the many side is the child table. Parent child, parent child. So what we're saying in here is we don't want to have any kind of a setup where we can have orphan records. So we wouldn't want to have an invoice still open that didn't have an associated vendor. We would not want to have an invoice line item open if the associated invoice was gone. If you have that, if you've got a child record with no parent, it's what's known as an orphan record. All right, you don't want to have something like that happen. All right, so what the author talks about in here is operations that can violate or cause this orphan type of thing to happen. One is deleting a row from a primary key table. As it says, if the foreign key table has one or more rows still connected, so one or more children still connected to the parent. Inserting a row into a foreign key table. That would be like inserting a new invoice and not having a vendor associated with that. Okay? Updating the value of a foreign key. So if we updated, again looking at that parent-child relationship between vendor and invoice, if we updated and we put in, let's say that we're putting in a vendor number into our invoice table, and we put in something that was incorrect that didn't exist in the vendor table, that would be the updating. All right. In the same way, if we put a primary key in and we change the primary key of a parent, and now there's nothing associated there with the children. Again, in all those cases, we're setting up the possibility for orphaned records. So an entity is a person, place, or thing. It's basically a noun. But it can also, it's possible for it to be a concept as well. All right? An attribute is basically an attribute ends up being a field. All right? I'm being a little bit general here. An instance, I don't even want to get into it with a database. I'm not sure exactly what they're talking about. So what we're doing is we're modeling relationships between entities, and that's what an ER model indeed does do. All right? It's exactly what it does. We already talked about referential integrity. All right, with declarative referential integrity, and I think you'll see this a little bit later, but one thing that you can do here is you can have what are called cascades. And what do I mean by that? And again, I might be jumping ahead a little bit, but just in case, we'll talk here about cascading. All right, and in particular, cascading updates and cascading deletes. With a cascading update, what you're saying is if I change the parent, change the child to reflect that. So in other words, if I were to change a vendor ID in the parent table, change the vendor ID that exists as a foreign key in the child table as well. With a cascading delete, what that means is if you remove a parent record, then remove all associated child records. In all those cases, what we're saying is we do not want to allow there to be orphan records. All right? And again, that's what we're getting to in every case here. That's what we're talking about. Foreign keys we've talked about already, and we've talked about what orphan rows are. So there shouldn't be really anything that's new in there. All right, now they're going to start talking about normalization. And the idea with normalization is what you want to be able to do is you want to always eliminate redundancy, duplication of data. That's one of the key things that you're trying to do. So what you end up doing when you normalize a database is you end up creating typically more tables, but the tables themselves, again, typically are smaller. So you have more tables, but they're smaller. All right. Now, if we look in there, if you look, notice, for example, in the example that's right there, you've got a vendor name, and in the second example, they talk about redundant data. Look how many times the vendor name is in there. Look how many times the invoice number is in there. And in the first table, the vendor name is in there more than once. All right. So we don't want stuff to repeat. So they've kind of jumped ahead to the end and said, okay, here we are now in third normal form. And hopefully what you see is we've added more tables. And some of the tables, really all the ones that we added, are smaller tables. This is not all, this happens. This is more a frequent type of thing than it is an infrequent type of thing. Now, there are actually about 7 normal forms that you can go into. And the higher the normal form, the more refined your database is supposed to be. Now, this is third normal form, but let's talk about the other ones that are in there. Okay, you can have first normal form. And if you have first normal form, what that means is what's called a cell, or the intersection of every row and column must be a single or scalar value, and you must not repeat anything. So that's the first thing. In second normal form, every column that's in there that's not part of the primary key must depend on all of the primary key. And the third normal form says every non-key column must depend only on the primary key. And you'll see examples of these as we go on. From there, you typically go up to what's called BCNF, which is Boyce-Codd normal form. And those are some of the people who were involved in creating all the stuff for basically for working with relational databases. Then you've got fourth normal form, fifth normal form, and what's typically referred to as either domain key normal form, DKNF, or 6NF. So before we go into this, let's talk about why you'd want to normalize a database. We've already talked about this, and one of the benefits, you're going to have more tables. And since you'll have more tables, they'll be done in such a way that you'll typically also have more indexes or indices, and that'll make your retrieval of data much more efficient. So that's the first thing. All right. Next, since each table contains information about one single entity, each index has fewer columns and fewer rows. And that means that when you actually go in to try to retrieve your data, or if you try to do either data retrieval with a select, or insert, update, or delete, it'll be done more efficiently. And the basic one, the main one, is your data redundancy is going to be minimized. All right, that's what's driving this whole thing. So these are terms that you need to know here. Again, normalization. And what we're talking about with normalization is what we're saying here is when you're normalizing a database, you're trying to reduce dependencies and you're trying to make your database work in as best a way as you possibly can. All right, data redundancy. You want to minimize redundant data. Unnormalized data structure, which is, as it says, it's a data structure that has not been normalized. A normalized data structure is one that at least has gone through first 1NF or first normal form. And a normal form. One thing about these normal forms, they go up in number. All right, so first normal form is less than second normal form. But what second normal form supposes or expects is that if you're in second normal form, you must already have gotten into first normal form. If you're into third normal form, you must have already gotten into second normal form, which means you must also have gotten through first normal form. Okay? All right, indices. An index in a database is kind of like an index in a book. So if I've got my book right in front of me, and if I want to find out about normalization, I'm going to go to the index in the back of the book. And I'm going to go to the ends. And now I'm looking up normal. And it doesn't have normalization, but it has normal form. And it says page 290. Well, when you create an index in a database, you're doing the same type of thing. The fields that you will typically index in a database are either those that are used a lot in joins, or if there's certain kinds of queries. So if you're going to always be writing queries about a certain state, for example, you're always looking for different states, from the United States of America type of thing, then state might be something that you index. When you've got a column or a field that has a lot of distinct values, you might put an index on that. When a column is updated infrequently. Okay? So again, this is what I told you before. These are the third normal forms. Even though it goes higher than this, there's fourth normal form, there's Boyce-Codd normal form, fourth normal form, fifth normal form, and domain key normal form, which is also called sixth normal form. Typically, those are not used. All right? So most designers, as it says, they stop at third normal form. So look at these definitions here. First normal form. The value stored, again, in each data cell is scalar, so it's a single value, and you're not repeating things. The idea is if you go through there and you see you're repeating things, that means that you haven't broken your stuff up into enough tables. Second normal form, every column or every field that's not a key must depend on the entire primary key. And third, every non-key column must depend only on the primary key. Here's the other ones. I'm going to leave that up there for a minute. I don't feel the need to read those to you. We've already talked about the benefits here of normalization. Okay? So here's unnormalized data. You'll notice the vendor name has been put in there a bunch of different times. All right? You're repeating information. You should not have to do that. Ideally, you do not want to do that. So putting this into first normal form, all it says, now notice there's still some duplication, because when you're in first normal form, you're not done. That's the idea. You're not yet done. But putting this into first normal form like this, you're starting to make it better. All right? So here's first normal form. You'll notice that the vendor name is being repeated. You'll notice that the invoice number is being repeated. All right? But everything, all the values that are in there, they're all scalar values. And that's the important thing. All right. Here it says the invoice data in first normal form, but now we've added a primary key, which is an invoice ID. There's still duplication of data, but we're getting there. We're starting to work our way to where we want to be. Now in second normal form, what we end up doing is notice that we've got a table that's got an invoice that's got in it an invoice number and a vendor name and an invoice ID. All right? The idea is everything that we put in here in an ideal world, we will be putting this stuff in there only one time. There won't be any duplication of data. So again, this is a process. It's getting there. So we start to ask ourselves questions about this just to see if indeed, again, okay, are we, as it says, does all the vendor information depend only on the invoice ID column? Or is there other stuff? Does the terms column only depend on the invoice ID column? Does the account number only depend on the invoice ID column? And can the invoice due date and line item be derived from other data? In English, what it says is this. If our primary key is the invoice ID, that means given the invoice ID, can you figure out all of the other information? If you can, all right, then you're in second normal form. So what this says is if I have a vendor ID, I know all the other information that's shown there under vendors. All right, if I've got an invoice ID in the invoices, I can get all the other information that's in there. In terms, etc., all the other ones. So again, that was third normal form. And notice when you break it up into fifth normal form, it gets even bigger. All right? This is a process. We'll have to go through this in much more depth and breadth of coverage later on. Okay? Sometimes you normalize too much. So what you need to do is, as they say right there, is you need to denormalize. All right? And what that means is that you go from maybe third normal form back to second normal form. And the reason that you might do that is it's actually by normalizing too much, you're actually making your system work slower and not faster. And that's what they're getting to right there. I'm again going to skip all the MySQL workbench stuff that's in here. So you can take a look at it yourselves if or as you have a desire to. This is an example of an ER diagram. And you can also create these ER diagrams, just so you know. You can also create them from PHPMyAdmin. And it's in a way very similar to the way that you create them for MySQL Workbench. And that's it. So we've now finished the first 10 chapters. Next, we're going to go into chapter 11, which is on how to create a database, how to create tables, and how to create indexes. This is all involving data definition language or creating schemas for databases. All right, so we'll come back to that one in just a couple minutes.